All right, we're going to look at section 9.3 kind of quickly if we possibly can. We're going to look at transformations of quadratic functions. And we're going to apply those translations, and we're going to talk about two things, dilations and reflections. Let me begin by just doing a little drawing here of a little graph. And we've talked about how when you graph a quadratic, it's a parabola. It has an axis of symmetry. It has a vertex. And you have these kind of mirrored points because if you fold it on the axis of symmetry, each side would lay upon the other. Now, the graph that I have just done is approximately y equal x squared, which is the simplest version of a quadratic. There's no b, x, no c part. It's just the x squared by it. It's the simplest of versions that we can have. So what we're going to do is we're going to look at what happens when you do put a bx and a plus c. What happens to this graph when you do that? And what we're going to find is, I don't want that. What we're going to find is, I don't want that. That moves it left and right. It can move it up and down. And it can also stretch it or flatten it. So that's going to be interesting to see how that looks mathematically. So you have your basic thing. Again, I can say you can stretch it. You can, compress it. That's what we call that. It gets flatter. Or you can stretch it and it gets steeper. You can see it moving up and down. All right. So here's how I want to look at it. So let's say we have the function y equal x squared. And to do this really quickly, I'm just going to do -2, -1, 0, 1, and 2. If y equal x squared, right, then -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. Okay? That's what we would get. If we decided to do y equal x squared plus 3, let's say, then you'd see how this would give you 7, because if that's x squared right there, then plus 3 would give you 7, plus 3 would give you 4, plus 3 would give you that, plus 3 would give you that, plus 3 would give you 7. So what that's going to do is make all the y values go up 3 because you have an add 3. And that makes sense. So the graph would go up 3. To go back to here, what would happen then is the graph would go up 3. So the vertex would go up 3. It would go from here at 0, 0 up here to 0, 3. Look at it. See? 0, 3. All right. So let me do another one. What happens if you're dealing with y equal x squared minus 2? So here's your x squared column. But then when you subtract 2 from 4, you get 2. Subtract 2 from 1, you get -1. Subtract 2 from 0, you get -2. Subtract 2 from 1, you get -1. Subtract 2 from 4, you get 2. You can see the kind of mirror here of the 2 and the 2, the -1, the -1, and the vertex in the middle. So what happens is when you subtract 2, you're going to cause the points to drop down 2. So back to here, this standard graph would then go down 2. So the vertex would move to 0, -2, right? See it here? 0, -2 would be the vertex. And like -2, 2, and +2, 2. So when I go back over here, you can see how that fits our picture, roughly fits our picture. Well, let's do one more or two, because I want you to see something else. What if we had y squared equal 2x? Now remember, we're coming back to here because this is our x squared. 2x squared is what I wanted to say. So this is your x squared column. So you're multiplying everything by 2 now. So that becomes 8 and 2 and 0 and 2 and 4. So hopefully you can see it goes up twice as fast, which means this graph that's sitting here, all of a sudden, it's going to go up twice as fast. So it's stretched. Now, if I'd have multiplied it by a half, I'm not going to actually do it, but it would have flattened it out, would have compressed it. And there's one more thing that you can do, or that we're going to talk about doing, and that is what happens when you have like y equal negative x squared. So the coefficient of the quadratic term, or the square term, is negative. Remember, this is x squared here. So the negative or opposite of x squared would be negative 4, negative 1, 0, negative 1, and negative 4. And what that does, I can't really show it to you like I want to. Let me put this back where it belongs first. What happens then is the graph flips around and opens down, because you can see points like negative 2, negative 4, negative 2, negative 4, somewhere down here. Still got 0, 0, right? 0 over here, 0 over here. You got 2, negative 4. So over 2, down 4. And so that's how that works. Now, I did that to kind of lead us to this. So we're talking about vertical translations. So you can see the standard green graph here, or it can be moved up, or it can be moved down. And they're talking about when C is greater than 0, or when C is less than 0. But it should make sense to you that if you're here and you add numbers, you go up. If you're here and you subtract numbers, you go down. That's what that positive negative stuff is all about. So quite easily, I hope you realize this is your x squared. This is your base or original function, your basic function. And what are you going to do here? You're going to add 10. So it's going to move it up. It says describe what happens. It's going to move it up. And you can see here's the basic one, the standard x squared one, right? And then here's the new one. Moved up how many places? 10. So you went from 0, 0 to 0, 10. And you went from 2, 4 to 2, 14, because you moved up 10. Translated up 10. So these are not difficult once you realize that. So what happens here? This is your parent, your basic one, and you're going to move down 8. So here's your parent, your basic 1, and you can see everything's moved down 8. The 0, 0 goes to 0, negative 8. The 2, 4 goes down 8 to 2, negative 4. Same thing for over here on the other side. So it's going to be translated down 8 units. Why? Because you're subtracting 8. So that should make some sense. So here you have your basic x squared, but now you're adding 7. So that moves it up 7. This says down 7. This says left 7. This says right 7. Pretty sure the A is the answer. Up 7. What's this going to do? Here's your basic. What's going to happen when you do minus 3? You're going to go down 3. I hope that's pretty obvious to you. Like, this is not hard. We do some tough stuff. This is really not the tough stuff. Okay, dilations. Remember we said earlier let's say the green one is the basic one. If you can stretch it, make it go up steeper. That's if you multiply by a number bigger than 1. That's what that says right there. It's stretched vertically. It goes up quicker. Or you can flatten it by multiplying it by a fraction between 0 and 1. And that's what happens with the blue one here. So it makes it go up slower if you multiply by a fraction, like a half or a third or a fourth or whatever. So here, your parent would, or basic would be the x squared. So if you multiply it by a third, what's it going to do? It's going to flatten it. So you can see the green is the basic, and here's the flattened curve. Because you take those values that we had in our very first slide up there, and you multiply them by a third, you shrink them. You make them smaller, so it goes up quicker. You know, what might have gone up to here, you multiply it by a third, all of a sudden it only comes to here. So it's vertical compression. Let me go back to that graph. It's like somebody's pressing on these green ones and pushing them over to the, so it makes it more squatty. Okay, now it says describe how this graph is related to the original or basic. Well, two things are going to happen here. You've got a plus 1 moves it up 2. Up 1. You got a plus 1 moves it up 1. And then you got a times 2, which makes it go up faster. So I'm just going to say if this is the original, then it's going to go up 2. And instead of having that same exact pitch, it's going to go up faster. Let's see how that relates here. Aha, exactly. Moved up 2. So the blue was the, this was the original, or the x squared. So two things happened there. It's stretched vertically and it's translated up. So what happens here to the basic x squared? You multiply it by 2. Are you going to compress it or stretch it? And the answer is you're going to stretch it. Now there are two stretches here. One is stretched vertically, one is stretched horizontally. We've not really talked about that one. So what happens here? Here's your basic x squared. You're going to subtract 4, it's going to move it down. And you multiply by 1/2, which is going to compress it. So 4 down and then compressed. This says stretched vertically. No. This says compressed. Yes. And down 4. Yes. I believe the answer is B. Because then we get this horizontal stuff that we have not talked about. And the final thing is what we alluded to before, and that is if you have the negative of, or negative coefficient on the square, then you flip it across the x-axis. So this one, 3 things are going to happen. You've got the square. You're going to go up 1. It's going to be stretched vertically because of the 3, but it's going to be flipped across the axis. So if I am just saying, if this is like normal, then you're going to go up 1, but you're going to get like that. Now I said this is like normal. That's if it was a negative already. So I already took into account that it got flipped across the axis. Normal really would have been, open up. So you can say the negative causes reflection, the dilation stretched vertically. I said that, I believe. So 3 things are going to happen. It's going to go down 4, the vertex, go down 4, well, the whole graph, but You start with the vertex. It's going to flip across the x-axis or be reflected across the x-axis, and it's going to be stretched. This says compressed. No. This says compressed. No. This says it's reflected across the x-axis. It's stretched. Yes, it is. And translated down, and that would be true. Answer is C. Now, what you can do with that, what I'm saying here is you can look at then a function or an equation and pretty much know what the graph's going to look like. And, this is standard down to compressed. This is standard up to stretched. This is standard down to compressed flipped across the x-axis. This is standard down to stretched flipped across the x-axis. Well, because this one is not flipped across the x-axis because it opens up, then we know these two are not possible because they're supposed to open down because the coefficient's negative. So we can throw those out. And then we look at the standard would have a vertex here. We see it here down to, so that makes the answer A. But that's that stuff that well, I don't know where that went. There's a different question, and oh, there it is. The answer is A. But that's the stuff that's the power of learning about all this algebra and how these equations and functions work.